Previously, we learned how to classify things as acids or bases, and if it wasn't one of those two, then it would be a neutral substance. Now we're going to talk about some characteristics that we can find of acidic, basic, and neutral solutions. These characteristic properties will help us to identify whether a solution is acidic, basic, or neutral. The first characteristic property we're going to look at is taste. Of course, taste cannot be done in lab because you should never taste anything in the laboratory course. But at home, you can decide if something's acidic, basic, or neutral dependent upon its taste. You'll see that solutions of acids taste sour. So what does that mean when we say it tastes sour? Well, the most common thing you can think of is probably citrus fruits. So lemons, limes, oranges, grapefruit, those types of things all have a sour taste to them. And of course, that is due to the acid that's present. Other things you might think of at home are sour milk or sour cream. Again, the sour flavor comes from the acid that's present in the sour milk and the sour cream. So what about bases? Well, bases taste bitter. And what does bitter taste like? Well, most people don't know this one as well. There is something called bitters. If you were a bartender, you might know that. But most people don't know this. The most common things that I can think of that are bitter are old coffee. When coffee gets older, some of the compounds in the coffee start to react with oxygen in the air and they form bases, and it starts to become more and more bitter. Another common household base that you can taste is chocolate. So dark chocolate, the darker it is, the more bitter it is. That means there's more base present. And what about neutral solutions? For neutral solutions, it depends on the source or the compound that's being dissolved. In the case of something like sugar, which is a covalent compound, it'll taste sweet. In the case of something like salt, table salt, it'll taste salty. Some things have no flavor at all. We don't detect them at all. And some of them have other flavors, just not sour or bitter. The sour taste and the bitter taste have to do with acids and bases. Now let's look at indicators. These are things that are used in chemistry to indicate whether something's acidic or basic. So not too surprisingly, these indicators will change color dependent upon whether there's acid or base present. So solutions of acid cause indicators to change color. Notice that I didn't tell you what color. That's because every indicator has a different color that it shows. We also see that same thing for bases, that they can cause indicators to change color. And since these common indicators are used only to show whether there's an acid or a base, we see that neutral solutions do not cause indicators to change color. Which means that if we want to test if there's a neutral solution, we test it with an acid indicator and a base indicator. We find if neither of those indicators work, then that means we must have a neutral compound. And next we're going to look at a common reaction for acids and bases, and that is that acids react with bases, and unsurprisingly, bases react with acids. And the reaction between an acid and a base creates a neutral compound. So this is called a neutralization reaction, and this is a very important reaction that we'll be looking for later. We're going to be saying anytime you see an acid and a base together, the first reaction that's possible will be for them to react with each other to form something neutral. And of course, we do not see this reaction for neutral compounds. They do not react with acids and bases to form neutral compounds. They may react with them and do other types of reactions, but they do not do a neutralization reaction with acids and bases. And a final characteristic property for acids, we see that acids will react with active metals to produce hydrogen gas. And this reaction is used in two ways. Sometimes we want to find out if we have an acid present, we'll put in an active metal. And other times we might want to find out, do we have an active metal? And for that we'll add an acid to it, and if it does react, then we know it's an active metal. And this is one of the reactions we'll be talking about very soon in this class. And for bases, a specialty characteristic is that they make the skin feel slippery when you have them on contact with your skin. Now the reason is they actually are reacting with parts of the skin, and they're actually taking off a layer of that skin so that it'll start to feel slippery. And why we want you to know this is that later in the semester, we're going to be using some bases, and we want you to know that if you spill this on your hands, it will burn. It doesn't feel like a burn. You don't feel it. It has a cold burn, but it will burn your skin off, and so you want to be particularly careful with these bases. If you notice that your hands are slippery, make sure that you wash them off so that you do not have any base left on you, meaning you'll protect yourself from getting burned by that base. There are 3 theories of acids and bases. We're only going to talk about 2 of them in this class because they're a little bit simpler. And we go from the simplest one, which is the Arrhenius theory of acids and bases. And that states that acids are substances which ionize in water to produce the hydrogen ion, and bases are substances which ionize in water to produce the hydroxide ion. A couple of things to notice: it's saying hydrogen is being produced or hydroxide is being produced. It doesn't say anything about the structure of the original compound, but we've been teaching you a different way so that you knew what it would look like. But anything that produces H plus or OH minus is going to be either an acid or a base. Neutralization is a reaction that happens between an acid and a base, and it is always something with an H plus and something with an OH minus coming together to make water. Usually the side product of this reaction is some sort of salt. The salt will vary. It's not always going to be sodium chloride, but it can be a various number of different salts depending on what you start with and what you finish with. We'll talk about the second theory of acids and bases later on. It's called the Bronsted-Lowry theory of acids and bases, and we'll talk about that one later on when we get closer to buffers and look at some different reactions that we need to know.